Hello, welcome again to class. Thank you so much for staying tuned. It's Great Light Academy. We're still on logarithm, our simplified logarithmic expression. Now, you notice that we're solving a number of questions, and that's good because the more questions you solve, it gives you more confidence and you're more prepared, because sometimes it's not enough to know the principle and the theory. It's okay to know them, but then people who form those questions are professors and highly intelligent people. They will play a fast one on you, put a tricky one, and then if you've not solved something that looks like it, you're going to fall. So the more questions you solve, you get to see it in the exam hall or in a test. You know that I've solved something like this, and then you know what to do. So that's why we'll continue solving more questions and then we'll move on. So this is a question. It's saying that show that log b in base a times log a in base b is equals to 1. Log b in base a times log a in base b is equals to 1. Now, there are several things you do. That's why you say solve the things you think. Sometimes you may just go straight, use some laws, use some principles, and then you get stuck, you come back again. That's how we solve math sometimes, or solve any of the things that involves calculation. In this case now, what you do is you use the definition of logarithm and you pick each one of them one by one. Now let me pick this one first. If I pick here, I say I have log b in base a is equals to what? Now let us pick them one and then assign a particular alphabet to it. If I pick this, assign a particular alphabet to this. I said let this be represented by let this be represented by x. And I pick this one. Let log in base b of a be represented by y. Now, having got this, I will now say, since this is the case, therefore, pick the first one. Log of b in base a is equals to x. What does it mean? If I use the definition of logarithm, what does it mean? The definition states the log of a number to a particular base is the number of times the base will be raised to give that number. Again, the log of a number to a particular base is the number of times the base will be raised to give that number. Now, if I do that here, the log of b to a particular base a is the number of times the base will be raised, the base to give that number b. So that means the log of this will mean that b is what? The number of times the base will be raised. The base will be raised to this x. So b is actually equal to this. So we have it as equation 1. We'll keep it now. Then we'll do the same thing for the second one. So this is the first one. We'll do the same thing we're done for this. Now let's do for this. Now we'll print this. This is log in base b of what? A. And we'll see at this point is actually equals to what? Y. Now let's separate these two. Now, what does it mean? The log of a number to a particular base is the number of times the base will be raised to give that number. Now, what this means is this. It means the base is raised to y. A will be equals to what? B raised to the power of y. This will be, let's call it equation 2. So we now have two equations already, equation 1 and equation 2. Now in this case, having got the two equations, we can do what is called substitution. Now I have equation 1. Let's bring the two equations. Equation 1 is b is equals to a raised to the power x. Equation 1. And then equation 2 is a is equals to b raised to the power y, which is equation 2. So what do we do? In substitution, I can substitute any one of them. Let me choose this. Put b into this. So let me say substitute, not use put. Substitute or put Substitute b equals to a in equation 2. This is equation 2, right? This is equation 2. So wherever I see b in equation 2, I'm going to put this. I'm going to put this. So let's bring the equation 2 out. What's equation 2? Equation 2 is a equals to b raised to the power of y. So wherever we see b, we'll put a raised to the power of x. So where did we see b? This is b. So this is a is equals to what? A. I've substituted this with this. A raised to the power of x. This y still remains here. Is that okay? Now from this you see that this bracket will mean multiplication. Is that okay? So it's still the same thing. We'll not point math by saying a is still the same thing as saying a, this, a raised to the power what? X times y. X times y is xy, right? Good. And do you agree with me that this a is the same thing as a raised to the power 1 is equals to a raised to the power x, y? Because any number raised to the power of 1 is still the same number. Even if it is 99, 12,000 raised to the power of 1 is still the same number. 20 raised to the power of 1 is still 20. So the same thing, a raised to the power of 1 is a. So you can, a raised to the power of 1 is a, or 1 raised to the power is the same thing as this. Now, having got this, now what do we do? This looks like this, so the both of them can cut. So since this is 1, this cancels this, right? So what do we have? 1 is equals to x raised to the power of 1, x times y. Is that okay? But what was x from the beginning? Or let's even switch it. Is it the same thing as saying, which is still the same thing as saying x, y is equals to 1. It's just the same thing, I just don't need to switch it, right? Now let's bring it here. Now what was y? What was x originally? From here, okay? What was x originally? What was x originally? X originally was what? Log a base b. So this